Is there only one Earth in the universe? Observations show that systems similar to our solar system are not rare. But among the nearly 10,000 confirmed planets, only Earth seems to be carefully designed. Not to mention distant places, in our solar system, there's no place besides Earth where humans can live. It's either a scorching world with raging volcanoes, or a planet with wind speeds reaching about 2,250 kilometers per hour. The rest have temperatures that would instantly freeze you. All are hostile environments. If we must colonize in the future, what would be your first choice? Now, using scientific data, I'll take you to experience the harsh environments of various planets, and then choose a new home that you like. First, look up at our Milky Way galaxy. If you tried to fly across it in a plane, it would take 100 billion years. If you're captured by aliens, when introducing where you're from, you should say you live on the Orion arm of the Milky Way, in a neighborhood called the Solar System, at address number 3, the third rocky planet. Yes, our solar system is just one of 200 billion stars in the Milky Way. And we live on its third planet. Among so many neighbors, only Earth seems to have won the universal jackpot. It has oxygen and oceans, suitable temperatures, and nurtures all life. But this winning ticket may not last much longer. The polar ice is melting, sea levels are rising. In thousands of years, large land areas may be swallowed by the ocean. This is not alarmist talk. It's a slow-motion crisis happening now. Earth, our only home, is becoming crowded and unsettled. So, if we want to create a backup for human civilization, to continue developing and expanding, we must turn our eyes to deep space. We must leave Earth, this beginner's village. And your first stop is the Hellish Mercury, closest to the Sun. Don't just look at the data, saying its atmosphere has a bit of oxygen, and think you can breathe there. It's a complete hell mode beginner's village. Its face has long been disfigured. The surface is densely covered with craters. These are all from 4.5 billion years ago, bullet holes left from the solar system's gang war era. Back then, asteroids were flying everywhere, hitting whoever was unlucky. Mercury was hit by a super cannonball, creating a huge crater nearly 1,300 kilometers in diameter. The shockwave spread across the entire planet like water ripples, triggering a Mercury quake. The force was so great it directly bent the crust, and even raised a mountain range on the opposite side of the planet. However, the era of collisions is basically over. Now, if you want to settle on Mercury, the biggest killer is temperature. A day here is as long as 58 Earth days. Imagine this. You stand on the sun-facing side, under a 450-degree superbulb that can melt lead. And once you step into the long night on the dark side, the temperature instantly plummets to minus 184 degrees. It's nearly 3 times colder than Earth's South Pole. Because of this extreme torture from both temperatures, Mercury's atmosphere has long been stripped away and escaped into space. The pitiful amount of oxygen left isn't enough for even one breath. It seems this brother closest to the Sun is not reliable. We need to continue looking at the next one. Let's go further out, leaving Mercury behind. Our next stop heads straight for Earth's sister planet, Venus. It's about 41.8 million kilometers away from us, shrouded tightly in a thick layer of atmosphere. Early scientists once thought this atmosphere was a protective shield, hiding a prehistoric Earth beneath, with tropical forests, vast oceans, and possibly even sloths and dinosaurs. It wasn't until the space age that humanity burst this bubble. To see its true face, in the 1960s and 70s, while the US was exploring Mars, the Soviet Union was exploring Venus, launching the Venera program. But Venus was like a forbidden zone, refusing visitors. Probes lost contact one after another upon entering its atmosphere. It wasn't until 1975 that Venera 9 finally transmitted back the world's first photo of the Venusian surface. No green paradise, only a dead, silent desert. What kind of hell lies beneath those clouds? Imagine a probe heading towards Venus. At an altitude of 80 kilometers, it hits thick clouds. But these clouds aren't water vapor, they're concentrated sulfuric acid, so corrosive they can burn through steel directly. This all comes from volcanic eruptions, blasting billions of tons of sulfur into the sky, mixing with water vapor to form this. Passing through the acid clouds and nearing the surface. Before our eyes are thousands of kilometers of ancient lava flows and dormant volcanoes. The atmospheric pressure here is 90 times that of Earth's, enough to crush a car into a scrap metal pancake instantly. But the deadliest thing is still the temperature. Venus's atmosphere is full of carbon dioxide, creating a completely runaway greenhouse effect, causing the surface temperature to soar above 482 degrees Celsius. Here, you would be roasted, crushed, and corroded by highly toxic chemicals all at the same moment. The environment is so extreme that even blocks of lead would melt like ice cubes. Therefore, probes landing here must be built from high-grade titanium alloy, like that used for fighter jets. But the most unexpected thing is, this hellish world might not be completely dead. Billions of years ago, Venus might have had oceans and simple life. Some scientists speculate, after the seawater boiled away, some life might have escaped to the high altitude and the relatively milder acid clouds. This means that, in the future, humans might ride specially designed hot air balloons to float and explore within Venus's atmosphere. But no matter what, the Venusian surface is absolutely off-limits for life. Forget about colonization there. We can only continue flying outward, heading towards the last rocky planet in the solar system. This time scientists think we might actually have a chance. It seems Mercury and Venus, these two siblings, can't accommodate us for large-scale settlement. Flying past Earth, we continue deeper into the solar system. The next stop is the highly anticipated Mars. Just the other day, Starship's 11th test flight succeeded. Musk optimistically stated that a Mars landing could happen by 2029. It feels like science fiction is about to become reality, right? But let's be realistic for a moment. Will we one day truly be able to settle on this red planet? On the surface alone, Mars is indeed the closest relative to our Earth in the solar system. A day is nearly 25 hours long. It has mountains, deserts, and enormous canyons. These canyons clearly tell us that it had flowing water scouring its surface in the distant past. Traces of this water are likely still locked away in underground ice layers today. But to obtain this source of life, we must first overcome the first major hurdle, radiation. 5 billion years ago, when the sun was born, it began blasting the entire solar system with high-speed, high-energy radiation. Without protection, we simply cannot survive. Luckily for us, Earth has a powerful global magnetic field, like an invisible super shield, that deflects and redirects the vast majority of lethal radiation. But Mars's magnetic field has almost disappeared. This means it has no protection. For millennia, solar radiation has been peeling away Mars's atmosphere layer by layer, like an onion. The water on it also boiled, with most evaporating and escaping into space. Ultimately, it only left us with a barren desert covered in iron oxide dust. For any future visitor to Mars, solar radiation is the #1 lethal threat. Even if you're wearing a spacesuit, high-energy radiation can still penetrate the protection, directly attacking the inside of your body, bombarding and killing living cells, and damaging your DNA. To live and work on Mars, the surface must have rigorous protective measures. To this end, scientists are taking a two-pronged approach. On one hand, developing special drugs, so that astronauts, after taking them, can clear radiation damage from their bodies on their own. On the other hand, for Martian habitats, they have developed a special polyethylene plastic shielding. It is lighter and stronger than metal, yet offers the same level of protection. It's planned to be directly integrated into the structures of future bases. Even if we manage to withstand the radiation with advanced tech, another ever-present native killer is waiting for us. Superdust. After radiation stripped away the moisture, this planet was completely covered by dry iron oxide dust. Here, there are often many tornadoes called dust devils, powerful enough to lift countless dust particles high into the sky. The trouble is, these small-scale events can escalate into a global disaster at any time. When the sun heats the surface, causing hot air to rise suddenly, it forms dust devils. They spin in the cold air, sucking up fine iron oxide dust, shooting straight up to the upper atmosphere. These dust devils can be as large as a football field, or as small as 1 meter in diameter. Scientists have indeed observed that local dust storms on Mars continuously merge and expand, eventually evolving into superstorms that envelop the entire planet, even obscuring the surface from view. It's not just dust devils. Ordinary winds blowing across the surface can also stir up dust, forming storms that blot out the sky. This is similar in principle to the dust storms over Earth's Sahara, but on a much more terrifying scale. Vast amounts of dust pose huge problems for landing operations. This dust is as fine as baking flour. It gets into everything. Even the slightest wind can blow it into every nook and cranny, easily clogging precision machinery and life support systems. What's more, this dust itself generates electricity. When tiny particles rub against and collide with each other, they generate massive static charges. Just like when you walk on a carpet, static builds up, but the power here is astonishing. Between the dust particles, they can even generate electrostatic sparks as high as 20,000 volts. This is enough to instantly destroy all electronic equipment and life support systems, paralyzing the entire base. Therefore, when considering landing on Mars, we must thoroughly understand the behavior of this dust, its condition, electrostatic effects, and all chain reactions caused by wind-blown particles. Perhaps one day, we will finally conquer Mars's harsh environment, but its harsh nature dooms it to never be a world that feels as warm and welcoming as home. Leaving Mars, we will continue our journey, heading towards the next category of worlds with even more extreme challenges, the gas giant of the outer solar system, Jupiter. Let's start with something visual. This guy is so massive, you could fit 1,300 Earths inside it. But it is a complete gas planet, with no solid surface for you to stand on. Its upper layers are madly spinning, even counter-rotating cloud bands. The entire planet is ravaged by perpetual storms and super high-speed winds. Jupiter rotates ridiculously fast, completing a rotation in about 10 hours. This frenetic spin drives east-west hurricanes, tearing the atmosphere into distinct striped bands. When these high-speed cloud bands collide, they birth the most terrifying storms in the solar system. The most famous of these is the Great Red Spot, which is 3 times larger than Earth. Up close, its edges are turbulent vortices, with wind speeds exceeding 400 kilometers per hour. The outer edge spins extremely fast, while the interior is relatively calm. Its structure is much like a hurricane on Earth. But the key difference is, hurricanes on Earth are fueled by the ocean's heat. They dissipate upon making landfall, lasting 2 weeks at most, whereas Jupiter's Great Red Spot has been raging for over 300 years. Because there is no land beneath it to sap its energy, this superstorm can only spin endlessly around this gas planet, but rotation alone isn't enough to make the storm last so long. Scientists have discovered Jupiter itself releases more energy than it absorbs from the Sun, twice as much. This indicates its core must be an intensely hot source of energy. If we dared to descend towards Jupiter's core, what would we experience? First, we'd be enveloped by immense water clouds. As the pressure soars, hydrogen, the atmosphere would be compressed into a strange liquid metallic hydrogen. At the very center core is a churning furnace with temperatures exceeding 22,000 degrees Celsius, where the pressure is 100 million times that of Earth's surface. What does that mean? Imagine an elephant wearing stiletto heels, standing on one foot. To achieve the pressure at Jupiter's core, you would need to stack 1,000 elephants like this, on the foot of the bottom one, all balanced on a single stiletto heel. In such a place, a human would be instantly crushed into elementary particles. What about not living in the core, living in the upper atmosphere instead? The answer is still no. And the key lies in one of its small moons, Io. Don't be fooled by Io's small size compared to Jupiter. It is the volcano king of the solar system. Its surface resembles Earth's Kilauea volcano, but on a terrifyingly larger scale, 100 times. An Earth volcano might cover 10 square kilometers in 5 months, while a single eruption on Io can cover 620 square kilometers. But volcanoes aren't the real killer. Before the lava even touches you, radiation will kill you first. Just 10 minutes on Io's surface is enough to get fried. Even more frightening, the volcanic particles spewed out by Io are captured by Jupiter's immense magnetic field. Jupiter's rapid rotation accelerates these particles into microbullets, forming a deadly radiation belt around it. How strong is this radiation? Even high in Jupiter's atmosphere, 320,000 kilometers away, an unprotected person could only survive for a few hours. If you flew directly through this region, within 10 minutes you would absorb a lethal dose of radiation. Your flesh and internal organs would be completely destroyed. With our current technology, We are utterly powerless against radiation of this intensity. So the conclusion is bleak. Jupiter is a planet we can never call home. We can only move on.
Let's see if the next stop, Saturn, can bring a glimmer of hope. Unfortunately, the answer is probably still no. Although Saturn's radiation levels are indeed lower, it is absolutely not a safe vacation spot. Seen from Earth, Saturn looks like a serene, ringed beauty, but its appearance is highly deceptive. Those famous rings look like a large disk, but they're not solid at all. They're composed of hundreds of billions of chunks of ice and rock, some as small as pebbles, some as large as cars, all racing around Saturn at speeds faster than a high-speed bullet. But Saturn's true danger lies in its atmosphere. Like Jupiter, it also has high-speed, counter-rotating wind bands. The clouds move at speeds exceeding 1,600 kilometers per hour, faster than the fastest fighter jet. At the edges where two wind bands meet, tiny particles collide and rub against each other, generating massive electrical charges. When the charge builds to its limit, it discharges between the cloud layers, creating apocalyptic superlightning. Earth's lightning is scary enough, right? Its instantaneous temperature can reach 28,000 degrees Celsius, capable of melting underground sand into a 4.6-meter-long glass tube. But compared to Saturn's lightning, it's just a tiny spark. A single storm on this gas giant can be large enough to cover the entire United States. And it doesn't last just a week or two, but rages on for years without stopping. In such an unstable atmosphere, with random lightning strikes and perpetual supersonic storms, attempting to enter its cloud layers is simply suicidal. So Saturn, like its brother Jupiter, is ruthlessly crossed off our list by us. We hurriedly pass by the bland-looking Uranus and head towards the true edge of the solar system. The environment there will begin to challenge and even surpass the limits of human imagination. Flying past Saturn, the final stop on our interstellar property tour is a blue giant far away at 4.8 billion kilometers. Neptune. To see it clearly from Earth, you have to go to the mountaintop in Hawaii and use the Keck telescope, powerful enough to see a candle on the moon. Its enchanting blue coat is not an ocean, but an atmosphere composed of hydrogen, helium, and a bit of methane. Methane absorbs red light, reflecting only blue light, so the entire planet appears in a dreamy, icy blue. Although there might be no water, Neptune has clouds. When methane freezes in its super cold upper atmosphere, it forms white clouds. Astronomers, precisely by tracking the movement of these cloud formations, measured a jaw-dropping statistic. The wind speeds here are almost the fastest in the solar system. In some latitudes, they reach up to 1,930 kilometers per hour. This is no longer wind. These are cosmic bullets skimming the ground. So the conclusion is very clear. Humans should never set foot on Neptune itself. You'll be torn to shreds instantly. But don't be discouraged. There's a substitute option nearby. It's Moon Triton. It has a solid surface with fewer storms, and it's large enough for us to live on. The question is, can we live there? Well, Triton's surface is absolutely uniquely strange in the solar system. What you step on isn't soil, but frozen carbon dioxide, carbon monoxide, methane, and large amounts of frozen nitrogen. It's like walking on a cosmic scale ice rink that crunches underfoot. But exploring here, every step is a life or death gamble at ultra-low temperatures below minus 230 degrees Celsius. Our current space equipment would become brittle and break down immediately. Rubber that is soft and flexible on Earth will become as hard as steel there, and then shatter like glass with a bang. Scientists are desperately searching for new materials that can remain flexible at these hellish temperatures. They've discovered that the secret might not lie in the material itself, but in its structure. For example, nylon, when made into fibers as fine as a human hair, can remain flexible even at ultra-low temperatures. The spacesuit for conquering Triton in the future will probably need to be made using this kind of weaving black technology. Even if you are wearing the ultimate spacesuit, another killer lies beneath Triton's surface: ice volcanoes. Do you see those mysterious black streaks on its surface? That's all evidence of its sneezes. Beneath the frozen crust is an ocean of liquid nitrogen. When slightly heated by the sun, the liquid nitrogen turns into pressurized gas, finally exploding through the ice crust, forming giant geysers that shoot up to 16 kilometers high, blasting black dust into space, which then falls back to the surface, forming those streaks. A world simultaneously filled with deadly cold and destructive ice geysers. Even if future technology allows us to walk there, it is absolutely not a place to easily call home. Thus, our solar system new home investigation report can come to a conclusion. So far from the sun, all planets are cold, dead wastelands. Beyond Neptune, only smaller, more frozen worlds like Pluto remain. Beyond that lies the endless unknown. Are we just trapped in the solar system to die? Of course not. The undefeated astronomers have long since turned their gaze to the more distant sea of stars. Our sun is merely one of 200 billion residents in the Milky Way, this cosmic first-tier city. And every single star here could have its own planetary system. At the Lick Observatory in California, these planet hunters, holding a star-hunting map containing 100,000 nearby stars, are intently screening the closest 2 to 3,000 to us. But you simply cannot see those planets directly. They don't emit light themselves and are a billion times dimmer than the host stars they orbit. So what to do? Astronomers use an extremely clever indirect method. They don't look at the planets, they look at the stars. Imagine a kid planet orbiting an adult star. The adult will also be tugged slightly back and forth by the kid's gravity, by staring intently at stars with giant telescopes. If they detect such a dance from it, then it proves there must be an invisible companion, a planet nearby, relying on this brilliant method of watching stars dance, assisted by powerful sky eyes like the James Webb Space Telescope. As of today, NASA has confirmed over 600 exoplanets. So what are these new worlds like? We can infer by calculating their distance from their star. The result, they found many monsters. There are super-Earths with 1,100 times Earth's mass, and also lava hells so close to their star their orbit takes only 3 days. Surface temperatures reach thousands of degrees. There, metals like iron and nickel not only melt, but even evaporate directly. Their atmospheres are filled with metallic vapor clouds. However, scientists firmly believe not all alien worlds are so violent. They have turned their focus towards those dim, gentle small stars. In the habitable zones around them, the temperature might be just right. Perhaps the next Earth exists there. Planets suitable for life must exist in the universe. But finding them is like searching for a needle in a haystack. Looking back on our solar system journey, from Venus's acid clouds to Jupiter's radiation, from Neptune's superspeed winds to Triton's ice volcanoes, you will discover most of the worlds we've discovered are far too hostile for life. After this big detour, the only place offering a glimmer of hope for human colonization is still our familiar Mars. If we can overcome the radiation there and the global dust storms, perhaps one day it could, under extreme circumstances, become a backup USB drive for human civilization. But before that time comes, the most important thing we should do is to cherish and protect our current home that won the universal jackpot. This unique, one-of-a-kind home